Imagine that I give you a coin which when flipped shows heads with a probability of 0.8, and I ask you to perform an experiment in which you keep flipping this coin and noting down the results until you get the first success. Here success is getting heads. Shown here is a result of one such experiment, where the first two tosses were failures and the third was success. In another such experiment, you could get success in the first toss itself, or in the 5th, or 8th, or even 20th toss. And on a particularly difficult day, it may even take you 100 tosses to get success. Although the probability of such an event is very small, it can still happen. In order to take the discussion forward, we will consider a variable. Let's call it S for success. We will define this variable as the number of tosses it takes to get the first success. Let us look at the range of this variable, written as RAN of S. That is the set of possible values for S. S can take values from 1 to infinity. If you get success in the first toss, S is equal to 1. If you get success in the second toss, S is equal to 2, and so on. Thus, S is an example of a discrete random variable, and it will have a probability distribution. Note that in this experiment, each coin toss is a Bernoulli trial. We can ask, what is P of S equal to 1? That is, the probability of getting success in the first toss. This is equal to 0.8. What is P of S equal to 2? That is the probability of getting success in the second toss. That means the first toss was a failure and the second was a success. P of S equal to 2 is 1 minus 0.8 times 0.8. 1 minus 0.8 is the probability of a failure, that is tails. Note that we are multiplying these two probabilities because the trials are independent. P of S equal to 3 means that the first two tosses failed and the third was success. P of S equal to 3 will be 1 minus 0.8 times 1 minus 0.8 times 0.8. That is 1 minus 0.8 raised to the power of 2 times 0.8. In this manner, you can work out the probabilities for all possible values of S. P of S equal to n, that is success obtained in the nth toss, will be 1 minus 0.8 raised to the power of n minus 1 times 0.8. Finally, if P is the probability of getting success, then the probability of the first success in the nth trial, which is P of S equal to n, is equal to 1 minus P raised to the power of n minus 1 times P. We have just arrived at a generalized expression for the geometric probability distribution.